This is just a quick video that was prompted by a response I got after posting a comment on one of my favourite YouTubers' channels this afternoon. It's a video I've been intending to make for a while, but this seems like an ideal opportunity to go over this subject because it is the fundamentals of what my channel is all about. And anyone that's been watching my channel will know that what I'm aiming for is to encourage fundamentals in engineering. And the exchange kind of goes against good fundamental engineering, and it's what I refer to as millennial arguing, where rather than sticking to the points of a discussion or a comment, someone will introduce straw man arguments and use those as the basis to further their point, which is unrelated to the original comment or the original point of a video or discussion. Now in this case the discussion's not that important, but it serves as a good example of this sort of cross-threaded thinking. Now the video was about the issues caused by cheap one-hung-low Chinese LED drivers to drive lamps in offices and labs and the like, and the fact that because they're not very well designed and they're built down to a budget, they cause a lot of flicker. And the video was about various ways of going about trying to reduce that flicker. Now in response to that, I posted a comment suggesting that maybe a solution would be to have a single centralized DC power source, low voltage power source, to drive all the lights rather than having a separate mains to low voltage converter on each actual LED. That's what I have in my labs, that's what I have in my workshops, and that's what my company uses when we install distributed systems. And we go about that route because my company designs and develops critical systems for use in hospitals, research labs, pharmaceutical manufacturing, that sort of thing. And it has to be ATEX approved, but that doesn't necessarily mean it has to be expensive or cumbersome or difficult. Now after I suggested using a single centralized power source, this individual decided that he was going to introduce straw man arguments and try to subvert what the point of my comment was, which was there is no real issue in using a single distributed power source. And he introduced all sorts of silly arguments about, well, you want to be able to individually control the lights, etc. And to be honest, whether you use a single centralized power source or that's DC or mains, it makes no difference. You can still individually control the lights if you really want to. Not that most people would want to individually switch every single light on and off in a big office block. It makes no sense doing that. So I just thought I'd set up a very quick demonstration here, because his argument, or one of his arguments against doing this, was, well, you need detailed knowledge of the inner workings of the systems to be able to implement this, and most installers won't be able to do it, etc, etc. And I pointed out this was incorrect, at which point he went off at a tangent to introduce yet more strawman arguments. Now my point here is that it's not difficult to do, and it's far simpler than the approach of having separate converters in each lamp, and that's what I've introduced here. Effectively what we have is a single centralized power source, just a DC power source, and because it's smoothed we don't get flicker. Each LED is a separate string of LEDs in effect, so they're all separate LEDs. Each one is separately current controlled, uses a single transistor, a single resistor for each one. Now this is easily transferable to larger scales. There's nothing complex in what I'm doing here. All you need is a current source. You could even have a floating current source if you want. It can be as simple or as complex as you like. But the point is, once you have this very simple arrangement, then you don't need the separate issues of converters on each lamp. And in addition, you don't have the danger of sending mains to each of these lamps with the prospect or possibility that that converter could fail and you have mains going to it. With this system that I'm talking about here, you only have relatively low voltage DC. Now if I turn this on, I've got this set to 10 volt supply, and as I said, each of these LEDs is effectively, or could be, a string of LEDs. And if we look at the current, it's drawing about 102 milliamps. So we'll go up to, this is currently 10 volts. If we go up to 12 volts, notice that the currents hardly change at all. These aren't perfect current sources, but they're easily good enough to cater for LEDs. If I go up to 15 volts, notice that again the currents hardly change at all. If we go up to 20 volts, so we're changing by about 10% with a 100% change in supply voltage, and that's easily adequate considering that your DC power source would probably be regulated anyway. And these are individually string regulated once you have this set up. So in other words, you can turn one of the strings off, which I'll simulate just by pulling the resistor out. I haven't fitted switches. And notice here that the current drops because we're now supplying one less LED. But if I go back down to, say, 12 volts, notice that the current changes very little. If we go on to 10 volts, again the current changes hardly at all. We can turn the lamp back on and it won't really affect the current flowing through the other chains. So in other words, you can implement this distributed system extremely simply, and that was the point of my comment, that it's extremely easy to do this. It takes almost no electronics. It removes all the mains going to the individual units. You don't have a penalty for the wiring because you have to run wires to them all anyway. The difference is this is low voltage wiring. It's far more reliable because you don't have any active electronics in the LED lights themselves, and it is a valid and perfectly viable solution, and none of the arguments he was making made any sense. He just either didn't know about how simple this is and doesn't understand the electronics, or he just wanted to start an argument. And in all honesty, just trying to start an argument when you're trying to look at a technical issue is not helpful. And that's, as I say, one thing my channel is all about, is getting back to the fundamentals of electronics. It doesn't matter if you're right or you're wrong. What matters is that you're heading for the same target as anyone else that is aiming to achieve the same thing that you are. And you're not trying to win an argument, you're just trying to find a technical solution. And this is a technical solution to the particular topic that was in question. The issue we have at the moment with rules and regulations is that we have people making decisions while they don't understand the fundamentals of what they're talking about. And as long as we can get back to fundamentals in things like electronics, then it makes far more sense. It makes the whole thing far more enjoyable. But don't assume I'm right, don't assume you're right. Try it both ways, fully assess it and see what the alternatives are, because doing it that way means you're going to be a better engineer, a better designer, and you're going to be able to handle any issues that come up, whether they are caused by a technical problem that you're trying to overcome, or a technical issue that has been introduced by a failure somewhere. So in short, when responding to a proposal made by someone, it's worth thinking through. It's not worth just dismissing, which is what this character did. He just dismissed the idea out of hand without really thinking it through. So the point of this video is to try to encourage all aspects of engineering to be considered. Don't introduce strawman arguments into discussions about methods or ways to do things. It doesn't mean I'm right, it doesn't mean you're right, it doesn't mean you're wrong, it doesn't mean I'm wrong. But unless you consider all aspects and different ways that things can be done, it's not very helpful, and you might end up missing a very good solution to a problem. And that's what my channel is all about. It's getting back to the fundamentals, and engineering and technology is no place for strawman arguments or ideas just that are unrelated to an issue that's been discussed. So as ever, comments welcome.